Here's another simple word problem from the law of cosines. Let's see how to solve this problem. Two ships leave a port at 9 a.m. One travels at a bearing of north 53 degrees to west at 12 miles per hour, and the other travels at a bearing of south 67 degrees west at 16 miles per hour. Approximate how far apart they are at noon that day. Since they begin to travel at 9 a.m., until noon, they have traveled for 3 hours. So between the starting point and 3 hours, how far are they going to travel? Let's assume that the port is somewhere here. We are looking at two ships. One travels at a bearing of north 53 degrees west. Let's show the north like this. I need 53 degrees towards west. The 37 degrees shown here is the direction from the horizontal line. Therefore, it's going to be 53 degrees from the vertical line. So the first ship is moving towards this direction. How far is it moving? The ships are moving for 3 hours. Therefore, within 3 hours, that first ship, which is moving at this bearing, north 53 degrees west, which means this angle is 53 degrees. Since that ship is moving at 12 miles per hour, within 3 hours from 9 a.m. until the noon that day, it should have moved for 36 miles. Therefore, this length should be 36. The other ship travels at a bearing of south 67 degrees west. Let me first complete the north-south line. That's south. From south, you need to go 67 degrees. From south, 67 degrees means from the horizontal line, I need to draw an angle which shows 23 degrees. So that's the direction of the second ship, starting from that same port, and it's traveling like that. So the angle from south towards west is 67 degrees. This angle right here is 67 degrees. That ship also moves for 3 hours. That also starts at 9 a.m. and travels until noon. Within 3 hours, it's going to travel at 16 miles per hour. Therefore, the distance traveled is 16 times 3, which is 48. So this length should be 48 miles. What we need to find is how far apart they are at noon that day. That means I need to find this distance. So how do you start this problem? Do we know this angle inside? Well, of course we know it. That angle is going to be equal to 180 degrees minus 53 degrees minus 67 degrees, which is equal to 60 degrees. Now, I know this angle and I know these two sides. Then, easily, by using the law of cosines, I can find the length right here. That's what we need to find in this problem. I need to find the distance between the two ships at noon. One ship is right here, the other ship is right here. First, I will label this triangle. I'm going to label this triangle as ABC. Let me label this point as A, the point right here as B, and the point right here as C. Now I need to identify the given lengths. This 48 right here is the length opposite angle B. Therefore, that 48 should be identified as lowercase b. The 36 right here is the length opposite angle C. Therefore, that should be identified as lowercase c. What we have to find is the distance between the two ships, the length BC. The length BC is the side opposite angle A. Therefore, I'm going to label that distance using lowercase a. In this problem, our target is to find lowercase a. We can easily write down the law of cosines for the angle A. If I write down the law of cosines for the angle A, we know it's going to be cosine A equals b squared plus c squared minus a squared, all of that's divided by 2 times b times c. Now we will go ahead and substitute the values. We know angle A is equal to 60 degrees. Therefore, it's going to be cosine 60 degrees is equal to B is equal to 48. Therefore, on the numerator, the first term is 48 squared plus C is equal to 36. Therefore, the second term on the numerator is 36 squared minus A squared. We don't know the value of A. Our target is to find A. So we'll simply write this as minus A squared. In the denominator, we have 2 times B is equal to 48 times C is equal to 36. Now we need to go ahead and simplify this equation. We know that cosine 60 degrees is equal to 1/2. 1/2 should be now equal to, on the numerator, we have 48 squared plus 36 squared, which is equal to 3600. That minus a squared. In the denominator, I have 2 times 48 times 36, which is equal to 1728. Well, I wrote it as 2 times 1728 because that way I can divide out the 2's from the denominator from both sides, because I can multiply both sides by 2. If I do so, well, of course, this numerator is one term. I can do the simplification. The 2's can be divided from 2 sides. Then I can multiply both sides by 1728. Then I get 1728 on the left hand side should be equal to 3600 minus a squared. When I multiply both sides by 1728, this term on the left hand side will be divided out by 1728 written on the right hand side. On the left hand side, I only have a 1. When that 1 is multiplied by 1728, I get this 1728. Now we can easily simplify this equation and find A. We have A squared equals 3600 minus 1728. Once you simplify that, you see that A squared is equal to 1872. I need to find the square root of that. You can see that 1872 is also equal to 144 times 13. From that, 144 has the square root. Therefore, when I take square root from both sides, if I look at this value, A should be equal to 12 times square root 13. Since all the units are given in miles, this is also going to be miles. So this is the distance between the 2 ships at the noon that day. If you do not like this simplification, it's completely fine to use the calculator directly and take the square root of 1872. In that case, you will see that your answer A should be equal to 43.27 miles. When you keep your answer like this, it's called the exact answer. When you keep your answer like this with decimal places, it's called an approximate answer. Usually, both formats are accepted in most of the classes. Thanks.